Alright, okay, welcome to this lesson with me, Teacher Kamanga. Now, in our lesson for today, we are going to consider a simple pendulum in physics. Alright, so a simple pendulum is one of the instruments that we need to understand. So, this is an instrument which is used to calculate time. Now, what will help us, it is a question that we have, which is going to help us in order to be able to understand what really a simple pendulum is and also what are some of the things that we need to know. So a simple pendulum is made by just simple things. Number one, we have a string. This is a string that we are seeing here. We have a string. Then we have a bob. Okay. So a bob, it is just a round object which we are calling a bob, like that. Okay. So these other imaginary movement that we're able to see, the movement from A to B, then from B to C. These are just imaginary positions. If we were to bring the bob here and release it, it will be able to make this movement, to be swinging like this, making what we call oscillations or cycles. Okay, so we need to understand oscillations or cycles. Now, what we need to know is that when this bob moves from here to C and back to A, this is what we call one complete cycle or one complete oscillation. So one complete oscillation is from A to C and back to A. That is what we call one complete oscillation. So we need to understand like that. Okay. Now what we need to understand is that the reason why we are saying it is 1 from A to C and back to A, it is 1. It is very simple. It's because from A to B, it is 1 over 4. Where is this 1 over 4 coming from? We are able to understand to say if this bob was to move from A to C and back to A, it will make about 4 movements. So it will make 1, 2, 3, 4. So we have about total 4 of the movements which this bob is going to make. Now what we need to understand is that from A to B, that is 1 out of how many? 4 of them. Then again from B to C, so if it moves from A to B, that is 1. From B to C, that is 2. So meaning that it will be 2 over 4. I hope we were able to get this. Now, since it is making 4 movement, and if here it is 1 over 4, even here if you like it is 1 over 4, again 1 over 4, meaning that we're going to have 1 over 4 times 4 of them. We're going to have 1 as our answer. So this is why we're saying that the movement of the bob from A to C and back to A, that is 1. That's why we're saying it is one complete oscillation or one complete cycle. Okay, that is what we need to understand. Now, a pendulum, it's just an instrument which is used to measure the periodic time. So we need to understand like that. Now, our question, the first question that we have, it's saying figure B1.1 shows a simple pendulum suspended on a clamp stand for determining the periodic time. Okay, so this is a simple pendulum that we're able to see there. Okay, so now the question is saying, what is meant by the periodic time of a simple pendulum? What is meant by the periodic time of a simple pendulum? So we need to understand in this case, in answering this question. So what is meant by the periodic time of a simple pendulum? We can answer it in 2 ways. So the first one is the one that I just told you. So the first one is the one I told you. How we can answer it? We can answer it like this. So the periodic time of a simple pendulum, it is the time taken for a bob to move from A to C and back to A. I hope you've gotten that one. The time taken for the bob to move from A to C and back to A. So we need to understand. So that is the periodic time of a simple pendulum. The time taken for a bob to move from A to C and back to A. That is the periodic time. This is how we're going to be able to answer it. Okay, I told you there are 2 ways. Another way on how we can be able to answer this question is to say, when we then say what is the periodic time. So the periodic time, it is a total time taken for one complete oscillation. The total time take oscillation. If you want, you can say the total time taken for one complete cycle. I want you to understand this term. I'm talking about cycle, not circle. So we're talking about cycle for one complete cycle, not one complete circle. This one is long, but this one is correct. So we need to understand when we're talking about this. So we are saying the periodic time, it is the total time taken for one complete oscillation or for one complete cycle. Okay, I hope we are clear now that. All right, let's come to B. So this one we are done. B, we are saying state two factors that do not affect the period of a pendulum. Two factors that are not going to affect the period of a pendulum. Number one, the mass of the bulb. The mass of the bulb will not affect, so we need to understand. Number two, the size of the bulb is also not going to affect the periodic time. So those are the two factors that are going to affect. The factors that are going to affect, we have a string, it is going to affect, and also we have gravity, which is also going to affect. So we need to understand. So our answer in this case, we have the mass of the bulb and also the size of the bulb. Okay, so we understand those two. We come to this one, we're saying this experiment is done on Earth and repeated on the moon. So there are two places. It is done on Earth and it is going to be repeated on the moon. So the question is, where would the periodic time be higher? Where would be the periodic time be higher? So the answer here, it is on the moon. On the moon, it is going to be higher. Then they're saying justify your answer because on the moon, there is less gravity on the moon. So like I've said, here, what affects the periodic time of the pendulum, it is the length of the string and also the gravity. So you're going to look at, when you compare the two, between on Earth we have higher gravity, while on the moon we have less gravity. So there, that is our answer, which is on the moon, and the justification is because there is less gravity on the moon. Okay, so I hope you get this one clearly. This is how we are going to be answering questions if what all have been given on the uh, pendulum. So we also need to understand, to remember the formula. We are saying T is equals to time taken over the number of oscillations. So we need to understand. So if you are told to say calculate the periodic time if the bulb moved from A to C in 0.6 seconds. So we need to understand to say from A to C, the movement or the oscillation is 2/4. Then where the number of oscillation is going to be 2/4 here, then the time it's going to be 0.6. So this is how we're going to be representing our formulas. We are able to use this one. All right, so this has been Teacher Kamanga. I hope you're going to learn something from this topic and also enjoy our lessons. Have a blessed day.